We can create a Docker image for each of our components, the API and the front end. Before we create the images, we need to create a bridge network. This is necessary while working locally if we want multiple Docker runs to work on the same network. We'll specify our bridge network for each Docker run. Our app was using a local MongoDB instance. Let's shut that down so we can use a MongoDB Docker image instead. Let's see what happens when we run the API without a database running. The API is waiting for a connection. Let's use curl to connect to the API. Because there is no database, the API returns an error. Let's start a database, this time using Docker. The publish option means we'll be able to connect to the MongoDB locally, which is really just to allow our local API to connect. Running the setup script creates our stores and menus. We run our curl command again to connect to the API. It works. The API is getting its data from the MongoDB running in Docker. Keep in mind, we're still running the API locally. Let's shut that down and switch the API to use Docker. Now we're going to build a Docker image for the API. But there's a problem. I'm running on a Mac, so when I built the API, I got a Mac binary. If I build my Docker image running Linux using a Mac binary, it won't be able to run. So let's use a Docker image to build the API binary to include in our API Docker image. The API we create needs to connect to Mongo using its hostname, which is Mongo. Before we build our API, let's change our Mongo database connection. Now, let's perform the Go build using Docker. We're running the Golang Docker image and doing the build. The mount option allows us to save the binary we're creating onto our local system. To demonstrate the binary problem in reverse, let's see what happens if we try to run the Linux binary we just created. Just as we expected, the Linux binary we created won't run on its Mac. But that's okay, since we don't need to run it locally. Let's use this very simple Docker file to build it into a Docker image for the API. We perform the Docker build, and now we run the Docker image to run the API. We ran the image detached. To see that it's up and running, we can look at its log. Our containerized API is waiting for a connection. Now when we run curl, there's the output that we expect. We need to create a Docker image for the front end. Let's take a look at the Docker file we'll be using for this Docker build. Just as we had to change the API to connect to the database using its hostname, we need to change the front end to use the API's hostname, API host, instead of localhost. Now we perform the Docker build, which will just take a minute. And it's done. We can now use Docker to run the front end. Let's connect to the front end using our browser. Our app works, and all of our components, the front end, API, and database, are running in Docker. Learn more at cloud.oracle.com/containers/pipelines.